All right, in the previous lab, we learned how to create a network dataset for performing network analysis and then practice route analysis, which was identifying shortest routes or quickest routes between two or multiple points based on road's network. And then we also practice closest facility to incidents, like closest police station to an accident. So in this video tutorial, we're going to practice other main functions in network analysis, including service area, origin destination matrix, and location allocation analysis. So in ArcMap environment, first of all, go ahead and load the network dataset that we created last week for Union County, Ohio. So if you click on add data, we had road_ND. When you add it, you'll notice that the junctions and edges and also the road itself will be added into the ArcMap. And also add the data for the block groups of the Union County and then close. Okay, so from Homeland Infrastructure Foundation level data website that you can find the link in the description, we would like to download 3 different shapefiles. The shapefile showing the location of the EMSs, and also location of hospitals and location of the fire stations. So for the hospitals, the locations, so if you click on download, so it will ask you the formats of the data, the output data. If you select the shapefile and then download, you will have all of the hospitals for the entire United States. Then you have to clip that with the Union County or your study region. For the fire stations, so there are too many records. As you can see, you need to zoom in your study area. So if I zoom in to my study region here, and then you can see that you can download the information. So click on download, again, shapefile, and then clip that with Union County or your study region. And also for the emergency medical services, so if you zoom in your study area and then download and then shapefile, and then clip the shapefile with your study region. So I already have downloaded these 3 different shapefiles, and so let me load it into ArcMap. So add data, so EMS, fire stations, and also hospitals, and add. Okay, so let me turn all layer off. After having all the data, we can begin our analysis. So from customize menu extensions, first of all, go ahead and check on network analyst extension and then close. And after that, right click on this gray space and then select network analyst. And here you can see that all the functions are active. And the reason is that because we already added the network data set into the ArcMap, okay? So let's begin our analysis. The first one is service area. So using this analysis, we are able to find a catchment area or service area around any location. Okay, so here if you have a location, you will find, for example, 5-minute drive from this point, or 10-minute drive from this point, or 15-minute drive from this point. It could be as a polygon, or it could be as a, for example, the line feature. And according to the ArcGIS, so service area generates polygons or lines that encompass all edges within a given distance, travel time, or other impedance unit from a facility. So service area is a more sophisticated version of buffer analysis, because buffer were based on Euclidean distance and it didn't consider the road network, but in service area is based on the road network and travel time along the road network. And for instance, again, a 5-minute drive service area from a point on a network includes all the streets that can be reached within 5 minutes from that point. So we would like to see how hospitals in this county serve people. And the question is, do all people have access to the nearest hospital within 20 minutes drive or no? And if not, where are the people who need to travel over 20 minutes to get to the nearest hospital in this county? Okay, so last time we calculated the travel time for each road segment in the Union County, Ohio, based on the speed limit. So I explained the process step by step, that how we can find the travel time, which was based on the minute, and also we calculate the travel distance in the previous video of the network analysis. So from network an analyst toolbar, go ahead and select new service area. So let me minimize this. And after that, select network analyst window. So here we need to tell what is our facility. So and our facility is the hospitals right here. So if you right click on the facilities, so the hospital is not on the network, is not part of the network. So we have to, when you load it, it becomes attached to the closest location on the network. Okay, so it snaps to the closest location on the network. So when you right click on the facilities, load location, and here I have to tell the location is hospital, and then click OK. So what happens is that now we can see that there's only one hospital, one main hospital in this county. So now the hospital is part of the network. And also, as we discussed in the last video, we can load, for example, if there are point barriers, line barriers, polygon barriers into the network, okay? So we don't have this kind of information in our study area. So the next thing is that go ahead and click on service area properties. And in this window, you have to go to the analysis setting tab, and your impedance or your cost field is going to be based on the minutes. So we're going to create the 5 minutes, 10 minutes, 20 minute service area. So it's based on the travel time. So the first of all, I'm gonna begin with 5 minutes drive. So I accept a break value for the 5 minutes. The direction is going to be, so you drive to the hospital, right? So it is toward the hospital, it's toward the facility, right? So you have to select the toward facility. It depends on the type of the problem, okay? And after that, you need to, so everything looks good. You need to go to the accumulation and find the total lengths and also total minute. And another thing is that you have to go to the polygon generation. So this is applicable when you have multiple facilities. For example, when you have multiple hospitals, sometimes they overlap, but you want to, for example, merge the overlapping part. So using this option, it will allow us to dissolve the catchment areas into only one area. So I select this one, merge by break value, but this is more applicable when you have multiple facilities, but here we have only one. So it doesn't have any impact on our results. So click apply and OK. So now we can click on solve button. And as you can see, so these are the roads or locations that can be reached in 5 minutes from this hospital. So let me add the roads here. And so these are the roads that can be reached in 5-minute drive from this hospital. So you can also create multiple service areas or catchment areas at once for different minute drives, okay? So I'm gonna create 5-minute drive, 10-minute, 15 and 20-minute drives from this hospital, okay? So I can create that at once. So if you go to the service area properties and analysis settings, so I'm gonna tell 5 minutes, and also, so if you separate that with comma, 10 minutes, 15 minutes, and then 20-minute drive, all other settings are the same. So toward facility, generate polygon, merge them, accumulate, and then apply and OK. And now if you solve this analysis, so you'll notice that it will create 4 different catchment areas. So between 0 and 5, so if you expand the polygons, which is the result, between 0 and 5-minute drive, so you will reach these areas or these streets. So I can add the roads. So between 0 to 5 minutes, all of these roads will be reached. Between 5 to 10 minutes from this hospital drive, based on the speed limit, these areas will be covered. And between 15 and 20, and then, sorry, between 10 and 15 and 15 and 20. So as you can see, not all people have access to hospitals in this county within 20 minutes drive. And so let me change the color for the block group and select hollow. So these areas in the white color, so these people need to travel over 20 minutes to get to the hospital in this county, okay? And another thing is that, so let me change, for example, if you're not happy with this color, you can right click on the polygon, properties, symbology, this one, and then apply and OK. So now it is a different color for the result. So instead of polygons, you could also generate lines. Okay, so if you go to the service area properties and go to the line generation and check generate lines and then apply and OK, and don't forget that you need to click on solve button. So instead of polygon, it will generate lines. So these are the lines that were used to create the polygons. So that is service area analysis, which is kind of a more sophisticated version of buffer analysis, but it is based on the network. And in this example, was based on the network travel time. Okay, so let's move on to the next function. So let me turn off service area layer and also hospitals and also roads. So the next type of analysis here is OD cost matrix analysis. And OD cost matrix create an origin destination cost matrix from multiple origins to multiple destinations. According to the ArcGIS, for OD origin destination cost matrix, it finds and measure the least cost path. So it could be based on the distance, it could be based on the travel time along the network from multiple origins to the multiple destinations. And it is a more general form of closest facility analysis. And we would like to estimate the shortest response time of EMSs as our origins to census block group nearby as our destinations, okay? So, and we would like to find underserved areas where the travel time from an EMS to the closest block group is over 8 minutes, okay? So, so here are our EMSs. Let me change the size. And we would like to find the shortest response from this EMSs. So these are our origins to the block groups. But the first fair question is, which location on the block group should I consider, okay, as our destination? And the answer is the center of each of these block groups. So we need to find the center of each block group by converting each of these polygons to points. So if you search, click search, and here if you type feature to point and feature to point data management, so your input feature is going to be your polygons or block groups. Okay, so I'm going to select the block group as the input. And the output, I'm going to save it in the place that I saved all of my data. I'm going to call it centers underscore BG block group. And then leave this unchecked because we're going to have the output as the center of the gravity of the polygon. So click OK. All right, so you need to wait for a few minutes, but after that, as you can see, it converted the polygons into points. Okay, so each point here, so let me change the color. For example, here, each point represents the block group, each block group. And so these points are going to be our destination. So we're going to find the minimum travel time from each of these EMSs to all of these the points, the centers of the block groups, okay? So to do that, we have to use the from network analyst extension. We have to use OD cost matrix, okay? So our origins, again, are going to be our EMSs, and our destinations are going to be the centers of these block groups. So from network analyst, if you select OD cost matrix, so after that, So you need to click on Network Analyst window, and let me minimize this. So we need to tell what are our origins, and we know that the origins are our EMSs. So load location is going to be our EMS. So another important thing here is that I'm going to sort the EMS based on the FID. And the reason is that because I'm going to, in the future, I'm going to connect this to create the map, join that to the block group to create the map. So I'm going to sort this based on FID and then OK. So these are going to be our origins. And for the destinations, if you right click on that, load locations, and our destinations are going to be our centers BG block group, and then OK. So we have 10 locations of as our EMSs. So let me change the color. So properties, symbology. So origin is going to be in the EMSs in the red color. So the centers, let me also change the symbology for the centers to the smaller size. And OK. So we have 10 EMSs here. We have 30 destinations. And OD matrix finds the minimum travel distance from each of these origin to all of these centers, but finds the minimum travel time. So now if you click on OD cost matrix properties, and if you go to the analysis setting tab, so our analysis is going to be based on the minutes, and we're going to find the distance from the origins to all of the destinations, right? So destination to find is going to be all. The output shape type here, so I'm going to show it as a straight line, okay? So, but our analysis is based on the network, but the representation is going to be based on the straight line. And now if you go to the accumulation tab, I'm going to have the total minute, total lengths, and click apply and OK. So again, all of our analysis in this video and the previous video are based on the road network, but here the representation is based on the straight line. So now if you click on solve, so what happens is that if you zoom in, for example, one of these EMSs, it finds the minimum travel time from each EMS to all other centers, okay? So now if you right click on the line, so you can see that it identified 300, 10 times 30, so it's 300 possible travel. So if you right click on that and then open attribute table, for example, for Allen Township as our EMS, so it finds the minimum travel time to all of these 30 destinations, right? So here is going to be, this one has to be 1 to 30, oops, from Allen to 30 destinations, right? So you can see that. So let me click on zoom to full extent. So it finds the minimum travel time from the Allen Township to all of these centers. Okay, so if I change the destination color, so you probably can see it better in yellow. Apply and OK. So, and again, if you right click on the line, open attribute table. Oh, so this one was for the Allen Township, and also the same for the Leesburg, the travel time, the minimum travel time from Leesburg to all of these 30 destinations, and so on. So 10 times 30 is 300 lines as the result. But we would like to identify the block groups or the centers that are over 8-minute drive from EMSs, okay? So for each destination ID, so if you go to the destination ID, so for each of this destination ID, I want to find the minimum travel time to EMSs, okay? So if I right click on the destination ID and then summarize it, and the total minutes, I'm gonna find the minimum, the total minutes, and also I'm going to save this as our output as DBF database file, and then save and okay. Do you want to add it? Yes. So here, this is our output. So for each of these destinations, which are the centers, it found the minimum travel time to the nearest EMSs. Okay, so these are the nearest, the travel time in minutes to the nearest EMSs. I'm going to map the minimum travel time to the nearest EMS, and we have to connect this table to the block group, okay, to map the results. So let me uncheck the lines here. So if you open up the output, so for the output, it's I'm gonna use the OID as a common field, right? Because I have to find a common field. It starts from 0. And for the block group, I'm gonna use FID, which starts from 0. Okay, so I'm gonna join these two layers based on FID and OID. So if I right click on the block group, join and relate, join, and here I'm gonna select FID, and from output I'm gonna select OID and keep all records and then click OK. So what happens is that for the block group, as you can see, the minimum travel time has been added, right? So I'm gonna map this one. Okay, so right click on that, properties, symbology, quantities, and then I'm gonna map the minimum total time. So as you can see, it's between 0.8 minutes, 0.9 minutes to almost 10 minutes drive. So that's the minimum travel time from each of these centers to the EMS, to the closest EMSs. So I'm gonna classify it into, let me click on classify. I'm gonna select the break values, for example, 2 minutes, and then 4 minutes, and then 6, and then 8 minutes, and don't change the last one because that's the maximum value. And then click OK. And so let me change the number of the significant digit to 2. So apply and OK. So as you can see, so for the centers, to make it better, so let me change the color for the centers to another color. So I think that's the, oops, origin, destination. So let me change this to, because I don't want to confuse it with the yellow color in the background. So probably the green color would be appropriate. Apply OK. So the greens are the centers and the uh, reds are the origin, and so these are the minimum travel time from the center to the origin. So as you can see, for example, traveling from EMSs to center here, it's gonna be between 2 minutes to 4 minutes. But from here, from this center to the nearest EMS for this one is over 8 minutes. Okay. And for example, here, so these are between 6 minutes and 8 minutes travel time, minimum travel time from the EMS to the center. However, in these areas, for example, in this area, you can see it's very close. So the minimum travel time from EMS to the center is less than 2 minutes. Okay, so the result makes sense. So, and if you want to make a map based on this one, if you go to the layout view, and then, for example, for the legend, insert legend. So for the legend, I'm gonna just, so let me move everything to the right. I'm gonna just select the block group. So block group here, and then EMSs, and finally centers block group. Okay, so centers BG here, and then preview, and then finish. So here you can see that, so we have the minimum travel time and also location of the EMSs and location of the centers of each of these block group. And then you can add North Zero, scale bar, and other information. Okay, so the last type of network analysis is location allocation analysis. And location allocation analysis chooses which facilities from a set of facilities to operate. Okay, so you have a couple of facilities, you just want to select a few of them. Okay, for example, because of the lack of funding, you want to just remove some of them and just select the best ones. Okay, so for example, again, given a set of existing fire station, which site for a new fire station would provide the best response time to the community? Or where should a factory be built to minimize the distance to distribution center? Okay, so let me turn all layer off, and I just wanna have the fire stations, and so there are, let me see, there are 9 fire stations in this county, and I'm gonna just select the block group. But for the block group, I wanna have it very simple, so I'll go to the properties, symbology, go to the feature, and then single symbol, apply and OK. Okay, so we would like to identify which facilities or fire stations would provide the best response time or the maximum response time for the community, which is our demand. Okay, so we want to select, so we had 9 fire stations, right? So we want to select out only 5 of them that provide the maximum coverage, and we want to get rid of 4 other fire stations. From network analyst, so let me close this one. From network analyst, close new location allocation. And here, let me minimize this and then click on network analyst window. So your facilities is going to be the fire stations, right? So right click on the facilities, load location, and here is going to be fire stations, and then click OK. So 9 fire stations have been added to the network. So they are now part of the network. Again, we would like to select a subset of these fire stations. We want to select 5 of them that provide the maximum coverage to the people in this block group. Another thing that I forgot to mention is that when you load the locations, so here, for example, for the fire stations, but do not click on OK if you already have loaded them into the network analyst. So here you could say the type of facility, okay? For example, you could add the fire stations individually and say that, okay, so this fire station is a required one. This one is a candidate, this one is competitor. So we want, but in this example, we would like to keep it very simple and assume that all of the fire stations have the same weight. So here you could, for example, change the weight for each of, so you could add them individually and then consider weight for the fire stations. So you prefer some fire stations have higher weight. So you could consider that in your analysis. But again, we're going to keep it very simple. So if you already have added that, click cancel. And so what are our demand points? So we already extracted the centers of the block group, right? So we're going to use this centers, which was here, block group underscore, so centers underscore BG. So we're going to use this centers as our demand based on the population of each block group. Okay, so because it has the population information, so when we downloaded the information, it has the population, for example, for the year 2010. So I'm going to use this one as the weight for the block group, okay, as our demand. So if you right click on the demand point and load locations, and here is going to be based on the centers block group. And but how we can tell, we can introduce the population of this block group as the weight. So under field, so here for the weight, you can say that, okay, so the pop 2010 is the weight field. And after that, so what happens is that each demand will be weighted by its population, because the population is very important as well. So click OK. So as you can see, 30 centers have been added, and they are weighted based on the population. Now, if you go to the location allocation properties and to the analysis setting, so the impedance is going to be based on the minutes, and travel from is going to be from facility to demand, because so it's obvious, because the travel is from the fire stations to the demand, okay? But if the facilities, for example, were supermarkets, so we should select the demand to facility. Okay, so it depends on the nature of the problem. But here, facility to demand make more sense. Now, if you go to the advanced setting, so here is very important that what is the type of the problem? When you select minimize impedance, so minimize impedance is when you would like to locate a warehouse, for example. So in that case, you should reduce transportation cost of delivering goods to the outlet and also minimize the distance the public needs to travel to reach to that warehouse, right? So in that case, the minimized impedance is appropriate. And maximum coverage, maximized coverage is when you want to locate, for example, fire station, police station, ERS, because emergency services are often required to arrive to demand point within a specified response time. So maximized coverage is used in these cases. Another example, for example, is pizza deliveries business. We need to use the maximize coverage problem time. The other important one is maximize attendance. Some businesses can benefit from this type of analysis, like coffee shops, fitness centers, medical offices, electronic stores, as we assume that the further people have to travel to reach these facilities, so the less likely they are to use these facilities, right? And the last one, maximize market share and also target market share. And in this analysis, you should not only know your own facilities, but also the competitors' facilities. And a good example is discount stores that they use this type of analysis to locate a set of new stores to compete other stores in the same area. So in our analysis, we're going to use the maximum coverage, and we're going to choose only 5 fire stations, okay? Among 9 fire stations, we're going to choose the 5 fire stations that provide the maximum coverage. For the impedance cutoff value, I'm going to set 10 because we're not willing to travel for more than 10 minutes from the fire stations. And everything else looks good. Go to the accumulation, select length, mile, and minutes, and then apply and OK. And now click on solve. So in this map, these lines, these brown lines, represent the fire stations that are associated with the demand points. Okay, so the best 5 fire stations that can serve the demand point. So let me move it here. So 1, 2, 3, 4, 5 stations, fire stations have been selected. And as you can see, within 10 minutes cutoff value, they can serve almost all of the census block group. So except for this one, they can cover everything. So these fire stations have not been included. This one, not included, not included, not included. So it seems like it would be better to have a fire station in, for example, in this area. So first of all, we can reduce the cost of the having multiple fire stations here. And if you move it here, you can reduce the disparities of access to the fire stations for these areas in this county. So if you right click on the facilities and then open the attribute table, so for each of these facilities, the facility type, it shows that whether they have been chosen or they are candidate. Okay, so the chosen are 5 facilities or fire stations that have been chosen, and the others are candidate that didn't, after our analysis, have not been selected. And another thing is demand count. It shows that each facility, how many they can serve, how many block groups. Okay, the centers of the block group. So for example, some of them, for example, this one serves 10 different block group. So can I see that? Yeah, this one can serve 10 different block group. And also, if you open up the attribute table of the demand point, and for example, if you see the location, for example, location 17, is not being covered. Okay, so this one, location 17, has not been covered, but all of them have been covered by a different type of facility because it is over 10-minute cutoff drive that we set in our analysis. And also, now if you right click on the line and open attribute table, so the name shows the fire station to the, so these are the facilities or fire stations, to the locations or to the centers, for example, center 20, 21, and so on. And also for each one, it shows you the total minutes. So, and as you can see, the total minute for all of them should be less than the cutoff value, 10 minutes. And that's the total minutes for all of them. And also the total length. So this one is minimized, but this one is not being minimized because we minimize it based on the impedance was based on the minutes.